What is up, Flutter devs? In today's widget workshop, we're building a color picker inspired by Photoshop. Our color picker displays the currently selected color on the left, a saturation and brightness selector in the middle, and a hue selector on the right. Now, the UX for this color picker doesn't make a whole lot of sense for mobile because it's relatively large. So in this workshop, we're actually going to be using Flutter for web. This would also be a really great widget for a Flutter desktop app. For example, Windows, Linux, Mac. Now, if you enjoy this video, do me a favor and give it a thumbs up. And if you like what I'm doing on this channel, be sure to press that red subscribe button. With that said, let's get into the workshop. Let's pick some colors. What we have on the screen here is my take on a Photoshop style color picker. Of course, it's missing a whole bunch of stuff, which is why we're here. We're going to fill it in. But you'll notice that we have a kind of dark mode looking dialog pop up right here. We have some color values over here on the right. And then we have 3 black boxes. And here's what we're going to build today. This box over here on the left, thin vertical box, is going to represent the currently selected color in our color picker. This big area here is going to be a 2-axis selection, which is going to combine essentially brightness and saturation. So we're going to select from a double gradient in here. And then over on the right side here, this vertical box is where we're going to select our particular hue or color. So over here is where you decide whether you're dealing with red or blue or green or orange over here on the right. And this big area in the middle is where you choose whether you want it to be a light orange or a dark orange, a grayish orange or a vibrant orange. If you've ever used Photoshop or something similar, I'm sure this will look very familiar to you. Let's jump in and figure out how we're going to implement that. Right off the bat, I already have a color set up for us. This is our initial color value. And you're going to notice that this is not a normal color or typical color in Flutter, because Flutter does have, and really Dart has, the concept of a color. But this is not a color, this is an HSV color. What does that stand for? It stands for hue, saturation, and value. The hue is essentially which color you've selected. Again, red, orange, yellow, green, blue, all those different colors. That's the H, that's the hue. Saturation is how vibrant the color is. If there's 0 saturation, that means you're dealing with grays. If you have full saturation, then you are as colorful as possible. And then V stands for value, which is interchangeable with brightness. Sometimes you'll hear about HSB colors, B for brightness. Those are exactly the same thing as HSV colors for value, V for value. The reason that we're using this type of color is because we're actually selecting those types of values. Over here on the right, we're going to have a hue selector, and in the middle, we're going to select between saturation and value. That's why we're using HSV colors. With that said, let's jump in and knock out the easiest part, which is the current color display. Over here on the left, we want to fill this whole rectangle with one color, which is the current color. So let's go ahead and make that happen. We already have a container here. We don't want it to be black. In fact, we're also going to give it some rounded corners while we're at it. So let's use the box decoration, which gives us color and border radius. For the color, we're going to take our HSV color, which again, I have sitting as a local property here. And this is set to red, by the way. 1.0 is the red hue. Sorry, that's alpha. Alpha is 100%, 0 is red, but actually 1.0 is also red. Then the saturation is 100%. And the value is 100%, which means it's the brightest red that we can get. Fortunately for us, HSV color can produce a regular color, an RGB color, which is what most of the Flutter APIs understand. But this is one of the great things about Flutter, because I came in here to work on this workshop, and I actually started to implement my own HSV color implementation until I realized that it was built in. There are a lot of these kinds of APIs where you don't expect it to be there, and it turns out you have it for free out of the box, which is really great. And it's also great, of course, that the HSV colors that are built in, they know how to go to RGB colors, which allows us in just a moment with this minor change to get the effect we want. But the one thing we want to add on top of this, just for a kind of visual polish, in my opinion, are some rounded corners. But we're just going to round the top left and the bottom left. We'll go circular 20 and then bottom left, radius circular 20. We'll save that. It'll restart. And now there's our color. This is the current color that we have in our widget, and now we're displaying it here on the left. As we implement these other two controls, when the color changes, we will see this presentation over here on the left change. So that's a real quick step one. In the next step, we're going to go work on the hue slider. Next, let's move on to the hue slider. We're going to start by just trying to paint this thing, and then we'll figure out how to actually select different hues. What we want over here on the right is essentially a color spectrum. Roughly speaking, if we use the colors as the primary colors from a physics perspective, going from the bottom to the top, we expect something like red, orange, yellow, green, blue, indigo, violet, and then red again here at the top. Let's figure out how we can get something like that painted here. We will implement this in the build color slider. That's what creates that rectangle on the right. And right off the bat, we're going to need a custom paint. And we're going to create a custom painter that we will call HuePicker Painter. Class HuePicker Painter extends custom painter. We will implement the two methods needed. We're always going to paint the exact same thing, so we don't ever need to explicitly repaint. We're not going to take in any configuration arguments. And then here in the paint method, we need to figure out what we're going to paint. First, we're going to need, so if we're going to paint a gradient, that we're going to need to first create a gradient and then use it as a shader to configure a paint, and then we paint the canvas with the shader. So we want a hue gradient shader, which we can create from a linear gradient. Now, a linear gradient, it's going to want to know where it begins, and it's going to begin at the, actually at the bottom center, because we're going to, the order that we define the colors, we actually want to paint it from the bottom up instead of the top down, just because that, the particular order of colors that we're going to use, when you use things like Photoshop, you will see them come from the bottom up. So if we're beginning at the bottom center, then we're going to end at the top center. And then most importantly, what we need to provide are colors. Now here's the problem. Linear gradient only understands RGB colors. So first, I'm going to show you an RGB attempt. We're going to notice that it looks terrible, and then we're going to see how close we can get to the correct solution. So let's start by just going through the different RGB colors. Here's red. Here's green. Here's blue, and then we'll circle back to red. That will give us a gradient. That gradient will go through all of those different hues. Now we need to turn this into a shader, and the shader wants a rectangle, which will be the size of our canvas. And so that will be, we'll take size and offset. Let's see, size, I forget this notation. Oh, I'm sorry, offset is not defined. We want the 0 offset. Okay, so this is a notation that I just learned recently. I used to define rectangles using a typical constructor. For example, previously I would have done something like this. Left top width height, so 0, 0, size dot width, size dot height. I did that for a long time because I didn't know any better. And rect does not have a constructor that takes a size. I went and I asked the team about this and I said, should we add a factory method or a constructor that takes in a size? And I was informed that actually there is this notation that you would never guess in a million years that takes an offset with an ampersand followed by a size, and what it gives you is a rectangle. So this turns into a rectangle. And because this notation is already defined, the team does not want to add any more size and scope to the framework by also offering a constructor that does the same thing. So this is how you construct a rectangle given an offset and a size. Now, given that shader, we want a paint object whose shader will be the shader that we just created. Then we will take our canvas and we will draw a rectangle. And it will here again be the same rectangle. We could have cached that, I suppose. And we will draw it using the given paint. Let's save that. First, well, let's specify. Oh, no, I just have a typo here. Just a moment. HuePicker Painter. Save that. Okay. Over here, you now see that we have a color spectrum, and it looks somewhat similar to what you're used to seeing in a color picker, but it definitely doesn't look right. First of all, you'll notice that there appear to be areas that are brighter than others, and that's because RGB does not hold the brightness constant. As we interpolate between the primary colors in RGB, we get darker values and then lighter values. So that's why in this area it kind of looks like mud, and then up here we have a really vibrant green. This simply does not cover the correct set of hues that we actually need to see in this gradient. So interpolating between standard RGB values is not going to give us what we want. I don't know the correct answer to this, but I have an approach that's close enough. What I did is I figured, okay, if physics tells us that the color spectrum is red, orange, yellow, green, blue, indigo, violet, and then back to red. Well, how many is that? Red, orange, yellow, green, blue, indigo, violet. That's what, eight color values? What if we create 8 different, actually in this case, HSL colors, or perhaps HSV colors. We can try that as well. But we'll create 8 of those HSV, or maybe we'll try HSL colors, and we'll just interpolate between them and hope they give us the right result. Again, I don't know if this is producing the desired result, but it gives us a visual effect that looks correct. So when I did this before, I used HSL colors, which are different from HSV colors. We'll try it with HSL colors first, then we'll come back with HSV colors and see if it still works for them. I'm not sure if it will or not. but just bear with me here. So we're going to create eight HSL colors. The alpha is going to be 100% for all of them. This is the number right here that we're going to mess with, the hue. The saturation for all of these is going to be 100%, and the brightness or the lightness is going to be 0.5 for reasons I don't want to get into. But what we do is we produce the RGB color. So this is the very first one in the spectrum. Now I'm going to take this and I'm going to replicate it a bunch of times. And if you know about HSL colors, you know that part of their definition is based on kind of a color wheel or a circle, which has 360 degrees. Therefore, the values for hue, the second column, ranges from 0 to 360. So what I thought was, why don't we just take 360 and break it up into 8 pieces? And so that's what we're going to do. And I happen to have these numbers written down, so I'll just drop them in here. 51, 102, 153, 204, 255, 306, 360. Now let's save that. Now the color spectrum is what we would expect. Like if you open up Photoshop, this is roughly what you're going to see. Notice that none of the hues look necessarily brighter or darker than any other hues. There are no muddy areas. We have vibrant red and orange and yellow and green and cyan and blue and violet back to red. And that's because of how these colors are defined. Like literally the 3 different components here, because we're keeping saturation at 100%, because we're keeping lightness technically at 50%, and because we're only varying the hue component, that's what gives us this consistent brightness and saturation throughout the spectrum. And this is one of the reasons, by the way, that we have different kinds of color spaces. Now, what I actually haven't tried at all is I don't know what happens if these are HSV colors instead. So let's just give that a try. If we can only use HSV colors, I think that's ideal. It's less to understand. So let's take HSV color, and that's going to be from AHSV. But instead of 50% lightness, we want 100% value. This is just a distinction between how the colors are defined. So let me just painstakingly copy and paste this down here. Let me change all of these final values to 1.0. And I don't remember if hue values for HSV go from 0 to 360 or 0 to 1. Let me see if I can quickly find the answer to that. Okay, yeah, they're from 0 to 360, just like HSL. Let's save this. Notice that we have the exact same spectrum. Let me do a hot restart just to be absolutely sure. And we'll refresh the screen. Yeah, as far as I can tell, the exact same result. So this is what we want, and now we have it using HSV colors instead of HSL. It's one less thing for us to figure out. It's one less thing for a developer to actually have in their head. Now we just have one color. But and also keep in mind, though, that the reason we had to do this stuff is because we have to actually give the gradient RGB colors. We have to convert every one of these HSV colors to an RGB color. And again, the only insight that I was working off of is that in physics, we talk about those 7 primary colors, and then we go back to red in the spectrum. So I took a stab at it and it gave me what I was looking for, so it worked out. This gives us the spectrum. Obviously, there's no selector on that spectrum and I can't click anywhere. So in the next section, we're going to actually extract this as its own widget, and then we'll begin adding some interactivity to it. Let's take the custom painter that we just created. Let's stick it inside of a widget called HuePicker, and then let's add a selector and dragability to it. We'll define a stateful widget called HuePicker. I'm going to come up here and grab this custom paint that we have. Instead, we're going to return a HuePicker. And then within the HuePicker, we will place that custom painter. And then we're going to want to display some kind of selector. We kind of just want a horizontal white line that shows us where in this spectrum we're currently basing our color. To accomplish that, we're going to surround our custom paint with a stack. And we're going to build a selector. The thing is, when we build the selector, to actually position it in the stack where it needs to sit, to position it vertically at the exact right place, we need to know how tall our stack is. For that purpose, we are going to surround it with a layout builder. With a layout builder, we're going to get a callback before we're painted, before we're sized. After our parent is sized, but before we build our subtree. And we're going to be given these constraints, which allow us to grab the max, well, actually we want max height. Max height in our case will be the height that our stack takes up. So now when we build our selector, we can position it at a Y value based on the height of our layout. We will define a method called buildSelector, and this is where we will create that selector. The hue percent, so we need to get to a number between 0 and 1, 0% and 100%. So we need to take in the selected hue, and we will divide that by 360 degrees. Remember that the hue values are from 0 to 360. We'll come up here, we will take in a double, which is the selected hue. We'll create a constructor that accepts it. We will require that. We should always receive a hue, which means up here where we use our widget, we need to actually give it a selected hue, which will be our HSV color dot hue. And that is, again, a value between 0 and 360. Back down here where we build our selector, we will take that hue, we will divide it by 360, and that will give us a percentage. We will then return a widget that is aligned. The alignment will be centered horizontally, but then we're going to take hue percent times 2 minus 1.0. And the reason we multiply by 2 and subtract 1 is because alignment goes from -1 to +1. -1 to +1. Therefore, if we are at 0%, if we're at, I don't know if that's top or bottom, but it's at one end of the spectrum. If we're at 0%, we need to be -1. 0 times 2 is 0, minus 1 is -1. If we're at 100%, we need to be at +1. 1 times 2 is 2, minus 1 is 1. That's what this math is for right here. And if you're curious about that, by the way, you can jump into the alignment constructor and you can read about what these X and Y arguments are actually for. This will explain what values you should be passing in. Now to actually draw this thing, the child of a line will be a container. The width will be as wide as our layout permits. The height, we'll just choose 3 pixels, and then we'll give it a decoration Actually, we don't even need the decoration. We just need a color. We'll go color's white. Let's save that. Well, we have an issue with our custom painter. We'll solve that in a moment, but notice that we have our selector up here at the top. As for our painter, I would guess that it's collapsing in on itself because it doesn't have a size. One way that we should be able to do that is with, let's see, size.infinite. Let's see if that gives us what we want. It does. So this size property causes the custom painter to take up as much size as possible rather than as little size as possible. Now we have our indicator here and we have our spectrum. We can also get ready for the ability to select one of those values. What we need is a callback. So we don't have the gesture detection in there, but what we will need is a callback. What we need to be able to do is up here in our HuePicker, we need to be able to say on hue selected, we receive some new hue, and then we will set state, changing our HSV color. We'll take that same color, but we will change the hue to the new hue. This is what we want to support. So we will declare a HuePicker callback. We haven't defined that yet, but we will. And then we'll just take in this dot on hue selected. So what should HuePicker callback be? We'll just come down here to the bottom and we will define a type definition. And we will say that a HuePicker callback is a function that returns nothing but takes a double as a hue. And now everything is as it should be. We're now ready to actually implement the ability to select a color, select a hue, and we will do that in the next step. With our spectrum drawn and a selector drawn, let's bring in some gesture detection so that we can click and drag as desired. We'll surround the stack with a new widget, which will be a gesture detector. When the user starts panning, we will invoke a method called onDragStart that we have not defined yet. We will also react to pan updates where we will call onDragUpdate, which we have not defined yet, but we will go define both of those right now. OnDragStart, we'll have drag start details. If there is no hue selected callback, then there's nothing for us to do. It doesn't matter. We'll just return. But otherwise, we will calculate a slider percent. We'll need to define this method, but we'll calculate slider percent passing in the local touch position. And then we will invoke onHueSelected, and we will get a hue from slider percent, another capability that we still need to implement. So based on the cursor position, we will determine the percentage selected, then we will convert that percent into a hue and we will send it out to our listener. Let's calculate the slider percent. We're going to grab the render box for our context. This allows us to look at the size of our render box. It allows us to know how large we are. So we will return 100% minus local position dot dy minus our render box height. So dy divided by our render box height. And then we will clamp that between 0 and 1. The reason we clamp it is because if the user drags outside of our bounds, we will get numbers that are in excess of 100 or below 0, these kinds of things. And we just want to stop at 0% and 100%. Next, hue from slider percent. Return slider percent times 360. Simple enough. Now we also want an on drag update implementation, which is going to do essentially the same thing that we just did. We could actually collapse these methods down if we want. For this little workshop, I don't think it matters. Once again, we fizzle out if we have no callback. Otherwise, we get the percent and we map it to a hue and we invoke our listener. Let's save that and see what happens. Let's see. Drag update details. Okay, we'll notice a couple things. First of all, the color on the left appears to show the correct hue that we're selecting over here on the right. So our callback is working and our calculation is working. What isn't working is the position of our selector. It is inverted from where we want it to be. Therefore, what we will do is come down here and take this little equation and we will say 1.0 minus the value instead of the value minus 1.0. And now it's in the correct place. And we can also notice that if I tap somewhere, it immediately jumps. Now we have hue selection working. And by the way, you'll notice that I already hooked up the HSB and the RGB color values on the right so that as we change these, those values change. And notice what I was saying before about the difference in the color spaces. As we drag up and down, the HSB, by the way, HSB, I can't remember if I mentioned this or not, HSB is exactly the same as HSV. B is brightness, V is value, they're the same thing. But notice that only one dimension of HSB changes as we drag up and down. But notice that all three dimensions of RGB change at different times. This is why we can't use RGB directly for these kinds of spectrums and selections. The mapping just doesn't work. The thing that we want to select is not a legitimate dimension in the RGB color space, but it is literally one of the three dimensions in the HSB color space. So hopefully you're learning some things about colors today. With that said, this step is done. In the next step, we're going to start painting this big rectangle, and we're going to bring in that saturation and brightness or value. The steps to implement the saturation and brightness selector is going to be very similar to the steps that we took for the hue selector. We're going to come back up here to the main widget and we're going to find the build color picker. This refers to the big rectangle. We are going to once again begin with a custom painter and then we're going to add the interactivity on top. Instead of this container, we will return a custom paint and we will create a custom painter called ColorPicker Painter. Now this time we actually do need to pass an argument to the painter. The painter will select saturation and brightness, but we need to provide it with a hue. Now let's go implement this custom painter. Now again, we're going to bring in a hue. And this time, the should repaint, we're going to return hue is not equal to old delegate.hue, which means that we need to constrain this to a color picker painter. When the hues change, we need to repaint, is what that says. Now, what are we going to do about actually painting this thing? Here again, I ran into a problem that I really didn't know the answer to. I ended up with something that seems to work, but there may be a better answer to this. And if you have the better answer, post it in the comments below. Let me know what the canonical way to do this is. But what I was thinking was, there are two dimensions that are varying here. We go from left to right, we go from 0 saturation to 100% saturation. And from top to bottom, we go from 100% brightness down to 0% brightness. So to kind of walk you through my approach here, let's just create a light gradient first, a gradient for the brightness. And let's paint that on here and let's take it from there. And to be clear, why I'm thinking in terms of two gradients is that we know that we have support for linear gradients. But as far as I know, and again, correct me if I'm wrong, but I don't think that we have support for essentially two-dimensional linear gradients or higher dimensional gradients. I don't think there's any support for that built in. And so I wasn't really sure how to approach this, and here's how I went about it. We'll start by creating a normal linear gradient. The colors for this gradient, we're going to start with white, and then we're going to go to black. We're going to start at the top center. We're going to end at the bottom center. We're going to create a shader. We're going to take offset 0 and size. That creates a rectangle again. Then we're going to create the light paint, which is a new paint where we set the shader equal to our light gradient shader. Now I will draw on the canvas. Let's see what we got. All right, from white to black. Again, if you've used Photoshop, you know that the very leftmost, side or position in a normal color picker actually looks like this. It looks like white to black because the left side has 0 saturation. So here we've drawn one gradient that seems relevant to what we want, but it's missing a whole second dimension. Let's draw the other gradient and see where we end up. So let's define a color with no saturation. HSV color from AHSV, fully opaque. We're going to use the hue that we were given. Saturation is 0, value is 1. Now let's take a full saturation color. It's exactly the same except the saturation is 100%. Now let's create a hue gradient shader. Now at this point, this has nothing to do with light and dark. This is just 0 saturation to complete saturation. We'll create a linear gradient. Our colors this time will go from no saturation to full saturation. And instead of being vertical, we're going to begin center left, and we're going to end center right. We're going to create a shader using the same rectangle as the others. We're going to create a hue paint. I guess let's call this a saturation paint. where the shader is the hue gradient shader. I'm going to change the name of that too. Really, this is a saturation gradient shader. And once again, let's paint this. Let's save that. Okay, and notice that we go from 0 saturation, but full brightness, all the way over to full saturation. Now, my thinking was, couldn't we just take both of these gradients and blend them together to get the actual visual effect that we want? And I'm not familiar enough with color spaces to know if this technically makes any sense, but this is what I did. Now, when I did it previously, I was using HSL colors. We're going to see if HSV works, but here's what we're going to do. This second gradient that we have created, in addition to the shader, we're also going to add a blend mode. We're going to use the blend mode called modulate. So not only are we going to draw this gradient, but when we paint it on the canvas, we're going to paint it using this blending rule. Let's see what happens. Check that out. Now that is at least pretty damn close to what you see in Photoshop, isn't it? We had one gradient up and down, one gradient left and right, and we blended them together in a particular way. Over here on the left, we have preserved our white to black, but over here on the right, we've obtained full saturation down, well, fully bright saturation, full saturation and full brightness, all the way down to full saturation and fully dark, no brightness. And watch this. As we select different hues, the whole gradient changes. So I'll say again, I don't know if every pixel of what we've drawn here is what it should be. And if you know what it should be and you know how to achieve it, you go down in the comments and you let all of us know. But this was pretty close. This was close enough for me to be happy with it. And so again, following the pattern of this slider on the right, we have now painted it. In the next step, we will extract a widget. We will draw a selector, and then we will hook up gesture detection. So we'll do that next. Next, let's go extract a widget, and then we'll start adding some visuals, a visual selector, and the ability to actually select a specific color. Once again, we will take our custom paint here and we will place it in its own widget. We will call this widget a ColorPicker. And we will pass in the currently selected HSV color. We now need all the components. We need the hue, but we also need the saturation and the brightness because we need to map the 2 additional dimensions within our spectrum. Let's create a stateful widget called ColorPicker. Let's return that same custom paint. We will take in an HSV color. It will be required. We will say, let's see, widget.hsvcolor.hue. Okay, and we still seem to be all right. Now, once again, we will create a stack, which will allow us to layer things, and we will use a layout builder to see what width and height we're actually dealing with. And once again, I'm sure we're going to need to use as much space as possible for our custom painter. There's our stack. And then let's get a layout builder. The constraints tell us how large we are. Once again, within the stack, we're going to implement a method called buildSelector, and we're going to pass in, this time we're going to need the width and the height. So we're going to pass in a size based on constraints.maxWidth and constraints.maxHeight. All right, so how are we going to build this thing? We need to figure out the X and Y position to draw it, and what we're going to draw is going to be a little circle. We will begin by calculating the saturation percent, which is equal to our HSV color dot saturation. It's already reported as a percent. And then we want our darkness percent, which is equal to 100% minus widget.hsv color.value. That is our darkness percent. Once again, the other widget we used, an align widget. Here we're going to use a positioned widget to get more control over the exact location. We want to set a left and top position for our selector here. The left, we're going to linearly interpolate between 0 and our available width at the saturation percent. So to be clear, we know how many pixels wide we are, right? We want to place this selector somewhere between the 0 position over here on the left and the width over here on the right. What pixel exactly? Whatever pixel corresponds to the percent of saturation that we have. 50% is here, 25% is here, 10% is about here, etc. And lerp double, that is linear interpolation. It picks a value between this first value and this second value based on this percentage. We're going to do something very similar for the top. We're going to lerp double from 0 to size.height with the darkness percent. Then the child will be a container, width 24 pixels, height 24 pixels, decoration. We don't want to fill in the whole thing. We just want a border, and we want it to be a circle with a border. Shape, box shape dot circle, border, border dot all, color, colors dot white, width of 3. And let's see, we have an error up here somewhere. You should be a comma. And let's see what this happens to give us. Suppose it's, let's see, where are we drawing it at all? I don't know. Let's output the percentages and just see what we're dealing with here. So saturation is saturation percent. Darkness is darkness percent. Save that. Saturation 1, darkness 0. So I think it should be up here. Let's also remove any clip behavior. Okay, so here it is over here. It was sitting outside of our stack. Now, I knew it was not going to be in the right location, but I didn't think it was going to be totally off the chart. The reason it's in the wrong location is because we are placing the top left. Well, the registration point for this circle is the top left. We are placing the top left of the circle at 0 pixels down and full width. What we want to do is surround our container with a fractional translation. And we want that translation to be an offset of negative 50% in both directions. Save that. And now you'll see that the center of the circle targets the actual place in our spectrum where our color corresponds. Unfortunately, because we have no gesture detection yet, we're kind of stuck up there. I mean, I guess we could manually change our color just to see what effect it has. So for example, here's our initial color when it loads. Here's the alpha, here's the hue, here's the saturation, here's the brightness. If we pull the saturation down to 0.5, it should be halfway between left and right. And there it is. Now it's halfway between left and right. Same thing if we drop this by half. It should be in the middle. And there it is in the middle. We need to hook up gesture detection to this, but we are at least now, we've extracted a widget, we've painted a selector, and in the next step, we'll bring that gesture detection in. Just like previously, the next step that we're going to work on is to offer a callback. So whenever we select a new color, we need to be able to notify our client that they need to update their color. So we're going to want a ColorPicker callback on color selected. We want to take this in here as a callback. Let's define that type definition. Type def ColorPicker callback. And that's going to equal a function that returns nothing, but takes in an HSV color. Back up here where we actually build our ColorPicker, we're going to provide a callback which receives that color. Then we're going to set state, and we're going to change our HSV color to the newly selected HSV color. And now, once again, we need to implement the ability to select a new color. This means we come in here to our stack and we surround it with a gesture detector. Once again, we're going to want onDrag or onPan start and onPan update. These methods don't exist yet, but we will create one called onDrag start and onDrag update. OnDrag start, drag start details. If there is no callback, we shouldn't do anything, we'll just return. Otherwise, we are going to need the % offset. This is the % in the X and the Y. We will calculate % offset, passing in the local touch position. Given that %, we will invoke the callback with the HSV color from % offset. Those are two methods that we need to implement now. We will calculate % offset given a local touch position. Once again, we will obtain our render box, which allows us to see what size we actually are on the screen. We will return an offset where the X value is the local position dx divided by the width of our box. And we will clamp from 0% to 100%. We don't want to go lower or higher than that. And then we will take 100% minus local position dy divided by the height. We do 1 minus because values get larger as they go down on the screen. So we're kind of inverting our percentages there. Again, we clamp it. That is now an offset that represents % in the X and % in the Y. Then we want a method that converts that. So we want an HSV color from % offset. We will return an HSV color from a HSV. the alpha is always 100%, or it's 100% opaque, we are going to retain the same hue. Remember, this slider over here on the right is what changes the hue. Our big rectangle in the middle only changes the saturation and the value. The saturation is equivalent to the X%, and the brightness or value is equal to the Y%. And that's how we calculate our new color. Once again, we have an almost identical method for drag update. You could kind of combine these into a method that's invoked from both of these if you wanted to. I'm not going to worry about it here. Literally the same thing though. And now let's save. And by the way, let's return our initial color to what it was. Okay, now let's drag around. So it's a little slow here in debug mode, especially with me recording. It will probably perform better in release mode without doing screen recording. But you can see that as we drag, this circle goes to wherever we're dragging. And you'll see that over here on the left, it respects wherever we've dragged. And we can also still change the hue. Once again, we can drag around. And now you'll notice, by the way, that saturation and brightness are both changing over here. Because we're no longer only changing the hue, now we're dragging around saturation and brightness. And you get a hex value down here as well, because if you're going to copy this into most other uses, you're going to want the hex value. But there is essentially a Photoshop style color picker. I guess, one final thing we could do is go ahead and clip the corners on this guy over here on the right, just to give us some symmetry. We probably should have done that earlier. In the HuePicker, let's see, let's clip our paint. So let's wrap this with a clip R rect border radius. We are only going to clip the top right and the bottom right. And I think we said 20 before. I can't remember. I'll have to go look. But let's see if that's close enough. That's close enough. And of course, our selector is now slightly off of, it overlaps that the clipped area, but I think that's okay. We could move the clip R rect on top of our stack and then it would clip the selector too, but I actually probably rather that this selector be totally visible. So now we can select a hue on the right and we can select a combination of saturation and brightness here in the middle, and we can see our currently selected color over here on the left, as well as see it in RGB and RGB hex over here on the right. So that is it for today's workshop. I hope you learned something, and I'll see you in the next one.